This example shows how standard barrier coordinates multiple threads so they all reach a synchronization point before any of them proceed. We set number of threads to 4 and construct a standard barrier with sync point number of threads on barrier, where on barrier is a completion function that runs exactly once when all participating threads arrive. Here it prints all threads reach the barrier and proceeding. In test barrier, we spawn 4 threads. Each thread sleeps for a staggered time from 0 milliseconds all the way up to 3000 milliseconds to simulate uneven work. Then it announces it's waiting and calls sync_point.arrive and wait. This call decrements the barrier's counter and blocks the calling thread until the counter hits 0. When the last thread arrives, the barrier invokes the completion function in one of the participating threads and advances the phase, and releases all threads to continue. Each then prints that it's proceeding after the barrier. Conceptually, a barrier is like a gate that opens only when every required thread is standing at it. Unlike a latch, a barrier is a reusable piece across phases. You can hit it multiple times in a loop. In this demo, we just use one phase. Key takeaways are that you should use barriers to enforce deterministic rendezvous points to ensure a group of threads start the next stage together, and centralize any once per stage logic in the completion function. This improves correctness and makes stage-based parallel pipelines easier to reason about.